Hello everyone. In this particular video, we will be studying a very important theorem of triangles, which is known as the midpoint theorem. Now, let me first explain to you what this midpoint theorem says, and then we'll write a the full statement of this theorem. So, what does it say? Suppose I have any triangle. This can be any triangle ABC. This can be a right angle triangle, acute angle triangle, obtuse angle triangle, any triangle. Now consider any two sides of this triangle. Any two sides of this triangle. So I am considering AB and AC. And find out the midpoints of these two sides. So suppose the midpoint of AB is D and suppose the midpoint of AC is E. So the midpoints are important. Now what this theorem says, obviously as you can see, this is a midpoint theorem. So it says when I join these two midpoints, I'll get a line. Now this particular line will be parallel to this third line. So this particular line, which is the line joining the midpoints of any two sides, this will be parallel to the third side, which we have not taken. So this will be parallel to BC in this case. And also the length of DE will be half of BC. The length of DE will be half of BC. So in this case, DE will be equal to half of BC. Now, if I have taken, suppose AB and BC as the sides, ABC, suppose I consider AB and BC, so let the midpoint of AB is D and let the midpoint of BC is E. So now if I join these two sides, this DE will be parallel to AC and DE will be equal to half of AC, and so for the third, suppose I take AC and BC as the sides, so the line joining the midpoint of those two sides will be parallel to AB and it will be equal to half of it. So let us first understand, or let us first write the statement of this theorem. So it says the line segment, which line segment we are talking about? The line segment joining the midpoints of any two sides of the triangle. Now again, the triangle is not which type of triangle is not mentioned, so it is valid for all type of triangles. Joining the midpoints of any two sides of a triangle is parallel to the third side. It's parallel to the third side. So it is parallel and the length is also half of it, and is half of it. So this is the midpoint theorem and it is very important. So let us move on to the proof of this particular theorem. So let's consider a triangle ABC. Now, these two are the midpoints of the two sides. So D and E are the midpoints. So when I say midpoint, that means this is a point which is exactly in the middle of this line. So that means this length and this length are going to be equal. So AD is equal to DB, right? And with the same logic, AE will be equal to EC. And we are talking about this line DE joining the midpoint, right? So now as you can see that ADE and DEBC, ADE is a smaller triangle, DEBC is a quadrilateral. So again, we don't have any congruency. We cannot prove any congruence in this. ADE and ABC will also will not be congruent, right? So because AD is a smaller triangle, ABC is a bigger triangle. Yes, they will be similar, but they won't be congruent. So I'm not, this theorem can also be proved using similarity, but we are going to prove it using some other We are going to use it. We are going to prove it using some other concept. And we'll take the help of quadrilaterals, basically. So now what I'll do, I'll have to make a construction. So what I'll do is, see, from this point C, I'll draw a line which is going parallel to AB. Let's simply draw a line which is parallel to AB. So now with this construction, this suppose I'll write this as M. So, okay. The construction part is draw CM parallel to AB. Now what this construction will help, let's see. Again, from point E, let us draw a line. I'll just extend DE and let DE meet CM at F, right? Let DE meet CM at F, right? So this DE is same. We are not, suppose DE is this, we are not doing any other thing. The DE line, we're just extending it to EF, okay? So now as you can see with this extension of DE to EF, we have got two triangles that might be congruent. Let's see if they are or not. So ADE is one triangle in consideration and EFC is another triangle in consideration. Now, why I'm taking these two triangles? Because obviously AE and EC are equal by hypothesis that we have taken, that we have assumed that E is the midpoint of AC. So AE is already equal to EC. Now, as you can see, these are the two lines, they are cutting each other. So we know these two triangles will be vertically opposite. So now let's consider triangle ADE and triangle EFC. Now what will happen with these two triangles? I am trying to prove that these two triangles are congruent. Now let's see what I have. So AE is equal to EC, right? By hypothesis. Then angle AED is equal to angle EFEE. FEC. Why? Because they are vertically opposite triangles. So what are vertically opposite triangles? Vertically opposite angles. So if these are the two lines that are intersecting, so these two are known as vertically opposite angles. They are always equal. And again, these two are also vertically opposite angles. These two are also equal, right? So basically, when an X is formed, so with X, you get two vertically opposite angles and they are equal. Now, when I've drawn the CM parallel to AB, this particular segment is also parallel to this line, right? So I will have, okay, consider these two lines, AD and CM. These are two parallel lines and AC will act as a transversal. So these are two parallel lines and this is a transversal, right? So whenever we have two parallel lines and a transversal, we get alternate angles. So basically like this. So parallel lines and a transversal, these are the alternate angles. They always form in the shape of Z. So you can see this is a Z, this is a Z. So this angle will be equal to this angle. So I have angle DAE is equal to angle ECF, and these we can say this is alternate angles. These are alternate angles. And why these are alternate angles? Because these two lines are parallel. If I had not constructed this line parallel to AD, then we could not have said that these are alternate angles. So there are two parallel lines and there is a line cutting these two lines. So these are the alternate angles that we get. So always in the shape of Z, the two above things have to be parallel. Now, so I can say these two triangles are congruent by which property? So I have two angles on one side. Okay, which two angles? These two angles and this side. So I can say these are congruent with SAS. Sorry, by AS. Two angles and one side. Two angles and one side. Right? So now when the two triangles are congruent, their corresponding parts are equal. Right? We say them as CPCT, congruent part of corresponding part of congruent triangles. They are also equal. So with this, I can say that AD is equal to FC. You can see if I just flip this, the FC will be over AD, and these two triangles will coincide, and C will coincide with A. So these two congruent triangles will overlap each other. So with this, I can say that AD is parallel to FC. AD is equal to FC. So from this, I got AD is equal to FC by CPCT. What is CPCT? Corresponding parts of congruent triangles. Corresponding part of congruent triangles. So when two triangles are congruent, all the sides, all the angles are equal, right? And also DE is equal to EF. Again by CPC. So now see, AD is equal to FC and AD is also equal to DB. So AD is equal to DB because D is the midpoint, and AD is equal to FC, we have just proved. So from this, I can say DB is equal to FC. DB is equal to FC. Now consider this quadrilateral, this four-sided figure, DFBC. Now what happens in this quadrilateral? DB and FC are parallel because of construction, and DB is also equal to FC. So these two sides are parallel and they're also equal. So one pair of sides are parallel and equal. So DBCF is actually a parallelogram. So this means DBCF is a parallelogram because one pair is parallel as well as equal. Now when this is a parallelogram, so automatically DF will be parallel to BC. And when DF is parallel to BC, the segment of DF, which is DE, will also be parallel to BC, which is our one part of the proof that the line joining the midpoints of the two sides will be parallel to the third side. So this proves that DE is parallel to BC. Now what remains is to prove that DE is half of BC. Now again, this is a parallelogram, so the other two sides will also be equal. They are parallel and they are equal. So DF is equal to BC because of parallelogram. Now what is DF? DF can be written as DF has two segments, one is DA and one is EF. So DE plus EF is equal to BC. Now with the corresponding part, we have proved that DE is equal to EF. DE is equal to EF. So instead of EF, I can write it as DE. So this becomes twice of DE. So twice of DE is equal to BC. So that means DE is equal to 1 by 2 of BC. So again, that proves out the second part of the theorem, that the line joining any two sides of the triangle will be half of the other side. Thank you.